Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all my fellows who are watching and my lecturer, Prof. Madia, Dr. Suraya binti Muhammad Tahir. So my friends and I, Ahmad Fathi bin Muhammad Asmullah 207627 and Muhammad Akmal Arif bin Muhammad Nazir 207573 will talk about kinetic of rigid bodies which apply on carry on luggage. Introduction. Why do we need traveling bag? We need traveling bag to carry our personal belongings with minimum force. Instead of carrying all the stuff with two bare hands, the bag itself have been fundamental for the development of human civilization. By using the application of the kinetic of rigid body, we can determine the forces and the acceleration acting on or by the carry-on luggage. Method approach. We use the topic translation motion of kinetic rigid body. By using the understanding of the equation of translational motion in section 7.2 and 7.3, there are two types of translational motion which are rectilinear motion, which we can resolve as y coordinates, and curvilinear motion, which can resolve with anti-coordinates. When a rigid body undergoes only translational motion, all the body have the same acceleration. So we can assume acceleration of g equals to all of the acceleration acting on luggage, and radial acceleration equal to 0. The equation of motion apply is rectilinear translation is the sum of fs equals to mass times acceleration of g uh, times x, and the sum of fy equal to magy, and the sum of moment at the point g, which is the center of the bag, is equal to 0. So and next we have curvilinear translation equation. So as you can see here, we will focus more on rectilinear translation equation. So I will pass to Akmal.
Okay, thank you, Fathi. Okay, as for the explanation of the luggage, to find the first of all, the external force will be acting toward the luggage so that the luggage can move. Since the force is acting on the luggage, meaning that the luggage move, it allows the luggage to move, which which a certain value of acceleration. Okay, to find the acceleration, determine all the external force, including the center of the gravity or mass. To find the acceleration of force, it can be calculated by using the formula given in section 70.3 or the formula that will be given by Fathi just now. Okay, the calculation of the force and the acceleration of the luggage. First of all, fix the coordinate each of the point and draw the free body diagram, including all the external force. Second, determine the location of the center of the mass for the luggage by using the formula of S bar equal to total S bar divided by total mass, or Y bar equal to total Y bar divided by total mass. And thirdly, find the weight of the luggage, which using the formula of W equal to mg, which is mass times gravity. After finding all of the component of the force that acting on the luggage, we can use the equation of motion, which is the formula that they given by Fathi just now. Find the total force that acting on the axis S and Y axis. So first equation is total force Fs equal to mass times constant acceleration of S. In the luggage case, the equation will be negative force B plus force P equal to mass times constant acceleration of S. The second equation will be force Y equal to mass times constant acceleration of Y. In the luggage case, the equation will be normal force A plus normal force B equal to minus Y equal to 0. 0 meaning the value of 0 because theoretically the force is act on S as Z, meaning that there will be no constant acceleration at Y axis. As for the third equation will be using the formula of moment. Total moment G equal to 0. As for the luggage case, the equation will be negative normal force A minus times by U1 minus force B times by H2 plus normal force B times by U2 plus force P times by H1 minus H2 equal to 0. As for U1, U2, H1, and H2, it is the length from the center. After finding all three equations, we can use the simultaneous equation to find the all force, meaning that after that we can also find the constant acceleration. after finding all the force and the constant acceleration, we can also use the formula to find the coefficient of minimum of the luggage, which is mu equal to force B divided by normal force B. In conclusion, there will be a constant acceleration at the x-axis, while there will be no constant acceleration at y-axis. I think that's all from me. Thank you.
Thank you for hearing. Bye.